Good morning everyone. I am Rihan Anjum. Currently I am pursuing my first BTech in Srinivas Ramanujan Institute of Technology in Anantapur. Now I am going to talk about implementation of queues using linked list with example. So now let us see what is meant by queues. Queue is a linear data structure that follows the FIFO property. FIFO means first in first out. In a queue, both the sides are opened. One end is known as rear end, another end is known as front end. Queues is essential in various applications like scheduling and buffering. You can see the diagram over here. The first one is NQ, which is the front end, and the DQ, which is rear end. Now let us know what is meant by linked list. A linked list is a linear data structure consists of nodes that hold data and data part and link part. Basically node contains two parts, which is one contains the data part and other one contains the link part. Linked list are dynamically grow and shrink, making them flexible for varying data sizes. Now let us see implementation of queues using linked list. Before this, let us see the operations on queues. We can do insertion, which is NQ, deletion, which is DQ, and is empty function, is full function, and peak function. These are the five operations which we can do in queues. So now let us see the implementation of queues using linked list. Queue can be effectively implemented using a linked list by maintaining pointers for the front and rear end. You can see here front pointer and rear pointer. When rear pointer moves, then front pointer moves, because if we do any insertions which is NQ, then we can do the deletions. We cannot do deletion without inserting anything. So front rear pointers, when rear pointers move, then only front pointer moves. These allows for uh, one time big O time complexity for both NQ and DQ operations. The linked list structure elements the need for shifting elements as seen in the array based queues. Now let us see the advantages of linked list queues. Linked list basis queues have no fixed size, allowing for dynamic memory used based on demand. Here it is a dynamic memory allocation. We allocate the memory dynamically. They avoid the overflow issues that can occur with the static arrays implementation, because here we can avoid overflow issues. And memory allocation is more efficient, as nodes can be added or removed without reallocating a large arrays. Now let us see the inserting of an element into the queue, which is made by NQ. Step 1, create a new node with given value and set new node of next to null. Before the first step in the inserting an element into a queue is we need to create a node which contains two parts, which is data part and link part. Then new node of next is new node of next is null. We need to initialize null to new node of next. Then step 2 is check whether queue is empty. We need to check that queue is empty or not, because we are doing insertion over here. So the condition for this case is front equals to null, and logical and rear equals to null. So if this is the condition for the empty. Now the step 3 is, if it is empty, then set front is equals to new node and rear is equals to new node. Then the step 4 is, if it is not empty, then set rear of next is equals to new node and rear is equals to new node. You can see the diagram over the right side of the slide, so which can be helpful for the insertion of an element. For in first case we are inserting the element 10, and in second case we are inserting the element 20, and in third case we are inserting element 30. Here you can see rear pointer is moving front because we are doing insertion. Rear pointer moves only when we are doing insertions. Now let us see the deleting of an element from Q, which is known as DQ. Step 1 is we need to check the condition whether the Q is empty or not. If the Q is empty, then we can't delete anything. So we need to check the condition Q is empty or not. For these condition is front equals to null, and logical and rear is equals to null. This is the condition for the Q is empty. If the queue is empty, then display queue is empty, because we can't do any deletions if the queue is empty. And then the step 3 is if it is not empty, then define a new pointer temp and set it to a front. And the step 4 is set front equals to front of next. We need to assign front of next to the front and delete temp, which is we need to free the temp because we are doing deletion over here. You can see the diagram over right side of the slide. Now let us see the displaying the element of a queue, which is display function. For these, step 1 is check whether queue is empty, because we need to display some if we need to display something, then there should be some elements in the queue. So front equals to null and rear equals to null is the condition for the queue is empty. If queue is empty, then display queue is empty. And if queue is not empty, then define a node pointer temp and initialize with front. Then display temp of data and move it to next node. Repeat the same until temp reaches to rear, which is temp of next is not equals to null. Finally display temp of next equals to null. Now let us see the example of these all operations in a one program. You can first we are initializing node, which is struct node, int data, struct node, in asterisk next, and asterisk front equals to null, asterisk rear equals to null. And we wrote the void insert function, and we declared here we are using a dynamic memory allocation, which is a new node is equals to struct node asterisk mlloc size of struct node. And we wrote the all the logic of the insert function as we discussed above in the above slides. And then we declared the void delete function, and we wrote all the logic of the particular function. And then we wrote the display function too. And then always program starts from the main function, which is int main. Here we are initializing the int choice, and we are displaying the we are printing that queue operations using linked list. Here are the various operations, which is insertion, deletion, and display, break, display. Then these are the operations of the queues. And if we choose the case 2, then we can do the deletion. Before that, we need to initialize something in the queue. So then go with the first case 1, because it something it initializes, then come back to the case 2, which is deletion, and then case 3, which is display. Then if you choose case 4, then it will exist, rather than if you choose any other option, then it will display you choose invalid choice. So this is all about the queues, implementing of queues using linked list. So thank you for this opportunity.